next we will do some exercises on this 3 address code generation procedure, and as I told you, like just like doing the parsing, so this is also a very cumbersome job, and you have to have patience for solving problems on this particular topic. So, first we take an example where we are having this arithmetic expression, say a plus b minus c into d. So, it is a simple arithmetic expression like this. So, first we try to draw the arithmetic, so the parts tree for this. So, this is E producing E plus E, then this E can give me I D, which is A, and then this E, from this E I have to generate this E star E. So, this E can give me within bracket E, then this E will give me E minus E, then this E will give me I D, which is B, and this E will give me I D, which is C, fine, and then this E will give me I D, which is D. So, this is the parts tree that is produced. So, next job is to number the reductions. So, this reduction will be done at the beginning. So, this is the first reduction, then this is the second reduction, this is the third reduction, after that this is the fourth reduction, this is the fifth reduction, this is the sixth one, this is seventh one, this is eighth one. So, how am I doing this? So, I am just looking from the leaf nodes, from leaf reductions from left to right, and whichever reduction is possible I am marking them. So, this is possible, so I marked it. After that you see the only thing that is possible is this one. So, I marked it as 2. After that only thing that is possible is this one. So, though this one is also possible, but you see that if you are looking from the left, then this comes first. So, the LR parsing, so it will be doing this reduction first, because it does a left to right scan. So, it will do this thing. Then so that way, so if you just do it, so you will be getting the reductions in this fashion. Now, I have to the corresponding action, if we try to look into, so you can mark the reduction number, and the corresponding action. Fine. So, at reduction number 1, so E producing I D. So, if you look into the rule, so it says that E producing I D, so this is E dot place equal to I D dot place, and E dot code is null. So, we can do that. So, E dot place equal to I D dot place. So, E dot place equal to A, and code is null. Similarly, at reduction number 2, I will have this E dot place equal to B, fine. At then reduction number 3, I will have E dot place equal to C. Now, this one, so this now reduction number 4, E minus E. Now, I have to get a new temporary variable. So, if you look into the rule again, so E plus E and E minus E, they are same. So, this E dot place equal to new temp, and then E dot code is concatenation of E1 code, E2 code, and generate E dot place equal to E1 dot place plus E2 dot place. So, that way so it will generate this new code E1 dot place plus E2 dot place. So, at 4, at reduction number 4, I will have this E dot place equal to T1, and I will generate a code, that E dot code, it will have T1 equal to E1 dot place minus E2 dot place, that is B minus C. So, this code will be there. Now, reduction number 5, at reduction number 5, I will have this E producing within bracket E. So, this E dot place equal to T1, E dot place equal to E1 dot place. So, that is equal to T1 and E dot code equal to E1 dot code, that is T1 equal to B minus C. So, that will be there. Now, at reduction number 6, so I will have E producing ID. So, this E dot place equal to ID dot place. So, that is D. Now, reduction number 7, E star E. So, it has to get a new temp. So, E dot place equal to new temp, that is T2, and then it will be having some code generated, E dot code equal to E1 code, E2 code and this multiplication. So, 5 code is T1 equal to B minus C, then 6 code is null. So, there is nothing, and then it will be generating another code, that T2 equal to E1 dot place multiplied by E2 dot place. So, E1 dot place is E1 dot place is from 5, that is T1. So, that is T1 multiplied by E2 dot place, that is D. So, this will have, this is reduction number 7. Now, reduction number 8, in reduction number 8 it is E plus E. So, a new temporary has to be generated. So, E dot place equal to T3 and then it will have the code like E dot code equal to E1 dot code. E1 dot code is null, for reduction 1 it is null. E2 dot code, that is 7's code is T1 equal to B minus C, T2 equal to T1 into D, and with that we will add another code which is this addition E1 dot place plus E2 dot place. So, E1 dot place is A, E1 dot place is sorry this E dot place, that is T3 equal to A plus T2, because this 7 place is T2. So, it will be doing like this. So, this is the final code that is generated. So, we have got T1 equal to B minus C, then T2 equal to T1 star D and then T3 equal to A plus T2. So, this is the final piece of code that is generated. So, you can generate 3 address code in this fashion. So, next we will be looking into another example which is again for arithmetic expression, but it is slightly more complex. Okay. So, this is for the expression minus A plus B into C plus D plus A star B plus C. Okay. So, this is the expression. Now, how to do this? So, the first of all I have to draw the parts tree. So, E producing E plus E, and then this E should give me this one. So, that is E star E. Now, this E should give me this unary minus E, unary minus, and this is E. This E should give me within bracket E, this E should give me E plus E, that is ID plus ID. So, this ID is A, this ID is B, fine. Now, this E should give me this C plus D. So, how to get it? So, this is within bracket E bracket close. So, this should give me E plus E, E producing ID, E producing ID. So, that is C, this is D. Okay. Now, this one, so this will give us within bracket E bracket close, and then again this plus has to be generated. So, this is E plus E. So, this E should give me E star E, this E should give me ID, that is A, this E should give me ID, that is B, and then this E should give me ID, which is C. This is the whole parts tree. Now, if I number the reductions, then this is the first reduction, this is second, this is third, this is fourth, this is fifth. Okay. Now, this is 6, this is 7, this is 8, this is 9, this is 10, this is 11, this is 12, then this is 13, this is 14, this is 15, this is 16, this is 17. So, we have got 17 reductions. Okay. So, we have marked them like that. Now, I have to have the code generated and the action and the code generation. So, at reduction number 1, okay, so I will have E dot place equal to A, no code is generated, and E dot place equal to A. At reduction number 2, okay, at reduction number 2, I will have E dot place equal to B. At reduction number 3, so I need a new temp. So, this E dot place, I need a new temporary variable E dot place equal to T1, and then I have to generate the code, that E dot code is T1 equal to A plus B. Then reduction number 4 is same E dot place and E dot code. So, they will be copied. So, this E dot place equal to T1 and this E dot code will be equal to T1 equal to A plus B. Now, comes reduction number 5. So, reduction number 5 is unary minus. So, I have to get a new temporary variable for place. So, this E dot place equal to a new temporary T2 and E dot code will be this E1 dot code, and then after that the minus of that. So, T1 equal to A plus B followed by T2 equal to minus of T1. So, that is the unary minus T1. So, that is reduction number 5. Now, reduction number 6. So, this will have E producing ID. So, E dot place equal to C. Then reduction number 7, E dot place equal to D. Then comes reduction number 8. So, this is I have to get a new temporary E dot place equal to T3, and after that E dot code will be this E1 dot code, E2 dot code, and then this addition. So, E1 dot code is nothing, E2 dot code is so this for the 6 and 7 their codes are nothing. So, they only so I have to have this code T3 equal to C plus D. So, T3 equal to C plus D code will be there. Now, reduction number 9. At reduction number 9, so this is within bracket E. So, this E dot place equal to T3 and E dot code is equal to T3 equal to C plus D. Now, reduction number 10, at reduction number 10 what we do, it is E star E. So, this I have to get a new temporary. So, this E dot place equal to T 4, then this E dot code, E dot place equal to T 4, and then E dot code will be this reduction 5's code, that is T 1 equal to A plus B, T 2 equal to minus of T 1. After that, and then that is E 1, and for E 2 it is 9. So, 9's code is T 3 equal to C plus D. These are put, and then I have to have the code of this multiplication, that is T 2 multiplied by T 3. So, T 4 equal to T 2 multiplied by T 3. So, that is the code for this line number 10. Now, line number 11, reduction number 11. So, that is where is reduction number? So, reduction number 11 is this one. So, E producing ID. So, this E dot place equal to A. Now, reduction number 12, E dot place equal to B. Reduction number 13 is E star E. So, I have to get a new temporary, E dot place equal to T 5, okay. E dot place equal to T 5, then reduction number 13. Now, I have to have the code part. So, this E dot code will be E 1's code. So, E 1's code is 13. So, this is code for 11, code for 11 is null, code for 12 is also null. So, this is the code that I have is T 5 equal to A plus B. So, that is reduction number A star B. Okay. Now, reduction number 14, so is E producing ID. So, this E dot place equal to ID dot place, that is equal to C, and 15, reduction number 15 is this E plus E. So, I have to get a new temporary, E dot place equal to T 6, and then at I have to have this code generated. So, E dot code. So, code for 13 is T 5 equal to A star B, and then I have got code for 12 code for 14, code for 14 is nothing, that is null. So, I have to now generate code for T 6 equal to 13 and 14 their place. So, that is T 5 plus C. Now, reduction number 16. So, this E dot place equal to T 6 and E dot code equal to this thing, that T 5 equal to A star B, T 6 equal to T 5 plus C. Okay. Now, comes 17. So, 17 it will have a new temporary. So, this E dot place equal to T 7, and this E dot code it will have this E 1 code, that is 10 code part. So, that is this one, the T 1 equal to A plus B, T 2 equal to minus of T 1, T 3 equal to C plus D, T 4 equal to T2 star T3. So, that is that is 10's code part. Now, 16's code part is T5 equal to A star B, T5 equal to A star B, T6 equal to T5 plus C. Okay. And after that I will have this 17 for that E plus E. So, I will get this code generated, that another line T7 equal to this reduction 10's E dot place, that is T4, plus reduction 16's E dot place, that is T6. Okay. So, this is the code that is finally generated, T1 equal to A plus B and T2 equal to this thing. So, like that. So, you can generate the corresponding code. So, the final code that I have is this one, that T1 equal to A plus B, T2 equal to minus of T1, T3 equal to C plus D, T4 equal to T2 into T3, then T5 equal to A star B, T6 equal to T5 plus C, and T7 equal to T4 plus T6. So, this is the code that is generated, and you see that this is perfectly fine with the high level statement that we have here. So, it is perfectly fine with that, and it is generating a proper code for that. Now, the way we are writing the code, writing this action. So, here the rule that we have is making us to write like this, that I have to have this gen part and this code. So, it was using this gen part. So, they are actually kept the codes are kept in a list sort of thing. So, as I was telling that at many places we can keep the code in a list, or we can use you can write it onto a file directly. So, if you look into some later rules that we have discussed in this course, like say array and all. So, there we will be using this function emit. So, instead of gen, so we will use the function emit. The difference being that when it is gen, so it is generating the code, and when you say emit, so as if it is writing onto some output file. And that way when it is emit, so it is just appending the code that is generated at this point with the already generated code. Whereas, with the gen part, so with every non-terminal the code part, so that is holding the full code for that particular non-terminal at that point. Like the example that we had taken. So, example that we had taken, so here there we have seen that this gen part. So, it was used for this E dot place and this thing. So, this generating for code for arithmetic expression. So, you are doing it like this, but here it is a bit cumbersome sometimes, like as we have seen that the same thing we are writing again and again, but that is because of the fact that it is on a list. So, we cannot output half of the list for a particular code. Now, so it will not have the other parts with which we will join. Okay. So, if it can be, so we can always write it in terms of emit functions, but we have to be a bit more careful, because as we have seen that in case of Boolean expression. So, Boolean expression you can write using this emit code, okay, and you can correct it putting them on a linked list and all. But for this gen code sort of thing, so for gen code sort of thing, so it is in a list, but in case of emit sort of thing, so you can put it onto a file directly. So, you do not have to have that much of overhead in doing the realization of those codes. Okay. So, in our next class we will be taking some more examples of these arrays and this complex programming language constructs, Boolean expressions, etc., and we will do some exercise to see how the code can be generated for those complex cases.